Oh, hello again and welcome to the VK6CS Fun with Amateur Radio channel. I've had the power supply on and running for about half an hour just to see if anything was going to burst into flames or explode or detach itself from the board and run off up the street. Everything seems okay. Now I'll just show you the meters. There we go. That's the HT voltage there. That's showing 2,800 volts. My timer relay is energized. It's drawing 115.78 milliamps. So that's all really happy. Now these resistors here, have I developed a lisp? These resistors here, yeah, maybe. These ones here, these ceramic resistors that are balancing the current across all the capacitors. They are 47k resistors at I think they're 10 watts. They've got W23 written on them, but I think they're 10 watt resistors. Now I think I calculated they're dissipating 3.8 watts each, and I can feel a little bit of heat coming off of those. Now I bought some 14 watt 100Ks, so I'll probably replace those before I actually draw a line under this power supply. I'll replace these with the 100Ks. Now I bought a little gadget today that I think is bloody marvellous, and I thought that I actually got this originally to look at the anode, the valve anode, the tube anode, so that because I want to run my GS35B within the manufacturer's specifications, so I'll check it, but I'm fairly sure I read somewhere that the anode radiator, actually I've got the thing here, where are we? There we go. There's the tube. I'll be very careful not to touch this on the 2,000 volts, of course. 2,800 volts, well, it's all fired up with a big copper anode radiator on it. I got this gadget so that I could just point it at the anode radiator, the copper anode radiator, and make sure the tube was running within specification. I thought, right, I'll run it to full power, run it key down for 5 minutes or 10 minutes. Well, initially, after about 30-40 seconds, just look at the anode temperature, and then you know, if it looks good, run it key down for 5 or 10 minutes just to give it a good old warm up, and then look at it again just to make sure it was running within the temperature specifications. And this is the little gadget that I bought. I think this is great. Supposed to be accurate to within 1 degree. As cheap as chips off the internet, and it's a non-contact thermometer. So I'll just fire it up. It's got a little laser on it, so I can tell, you know, the where it's actually looking. So I'm just going to look at one of these. Let's look at one of these resistors. It's timed out. There we go. And hold. So that's 70 degrees. Okay. How are the capacitors doing? Yeah, capacitor's 29 degrees. 54 degrees. I can't believe the temperatures are not even. Let's go back to that one. 63 degrees. 61 degrees. 62 degrees. Trying to keep the screen in the camera shot. 78 degrees, come on, get a life, get a grip. Can't believe that one's hotter than the others. Okay, let's just see if the glaze is having any effect on it. Now remember, this one right at the top here isn't actually connected, that's a spare. Excuse me. There. 22 degrees, well that makes sense. Excuse me, blimey. Okay, so the one that's not in use, 22 degrees. Fire it up, the one next to it there is in use. Again, I'm leaning around the bloody camera, so excuse the shaking. What was that, 54 degrees. Not that one. 61 degrees. $73 degrees. The actual heat coming off there doesn't feel uneven. Excuse me. I'm just going to see if I can... Hang on. Just a second. I've got a bit of paper or something. What is this? That's a anode converter circuit. Something that I can stand my refreshing beverage on. I do have a cup of tea here. See what the temperature of that is. That's saying 58 degrees. So my refreshing cup of Dilmar. Okay. So with the board itself, 19 degrees. Yeah. Okay. And a capacitor. The capacitors are about 30 degrees, but that's probably a bit of heat transfer down through the pins from the resistors, I suspect. It's one of the reasons why I want to change them. I want the whole thing to run as cool as possible. Yeah, there's nothing wrong with a nice, a little bit of warmth won't hurt it. In fact, a lot of stuff likes a bit of warmth to work properly. Thermionic tubes, for example. $82 degrees. Okay. Okay. Well, sure you get the picture. Put that back on, see if the diodes are happy. The temperature of the diodes. Oh, look at that. 22 degrees. Don't even know they're working. These rectifiers and these capacitors here are these rectifiers and these capacitors here are on holiday. They don't even know they don't even know they're at work. And the transformer. Yeah, 23 degrees. Admittedly, it's not loaded up, but I mean, it's just sitting there. It's just not bothered at all. Timer relay. 24 degrees. Yeah, okay. I'll just show you the timer relay actually operating. Excuse me. There you go. You can see that. Timer relay there. The little LED on. You can see the dip switch settings on there. Yeah. Okay. Well, that's quite interesting. Even though some of those readings are sort of reasonably high on those resistors, I don't actually think. Yeah, there's a fair bit of warmth coming off there. I think what I'll do is I will change those. I'll take those 47Ks out and I'll put the 100Ks in. These are 10 watt resistors dissipating 3.8 watts each. And if I put the 100Ks in, there'll be 14 watt resistors dissipating 1.8 watts each. So I think I'll do that. I'm not going to wire this. I'm not going to wire the end capacitor in circuit. I'm just going to leave it where it is as a spare. So I'll take the 47K off and I'll tack a 100K on there just as a spare. So that I've got some identical spares if I do want to increase the HT voltage. The only problem with that, of course, is if I did that, it upsets the scaling on my my rather nice meter. You know, because that's a really excellent meter for rescaling to, you know, times 100, 0 to 3000 volts. Obviously, if I made the HT voltage, you know, 3000 to 300 volts, then I'd have to get another meter, and if I get a 0 to 50 volt meter and then rescale that to 0 to 5,000 volts, it's only going to be, you know, it's only going to be about halfway through the full scale deflection. Whereas there, I think psychologically, you know, because it's almost pegging the needle there, and that's sitting there really happily on 2,800 volts, I think psychologically that's a much better setup. Okay, so excuse me, blimey. If I survive long enough, I'll show you the tube. Well, when the amplifier's up and running, I'll show you the tube under load, and I'll take the temperature of the anode radiator. Now, let's turn that off. So I think that test is, you know, that's been on now for 45 minutes. So if that's going to run for 45 minutes, it will run for 45 years. That's not a problem. That's more than happy. And when I put those 100Ks in there, take the 47Ks out and put the 100Ks in, it will be absolutely blissfully happy. It will take twice as long to go from HT to 0 once it's switched off, but you know, that's no big deal. Just pan that out again and down there, and yeah, this is quite a heavy tube. You can see there's the valve anode, so I've got to blow the air through that. You can see the meters and the components in the background. So when this is in the socket and it's running, I'll be pointing that thermometer at this anode radiator and just making sure that the temperature is well within the rated specifications. If it looks like it's running a bit hot, I'll just have to increase the air through it. Okay. Well, as always, I hope you found that interesting, and I'll thank you for watching, and catch you next time.